both sides by 5/4.
Absolutely. Because 5/4 is the reciprocal of 4/5. So if I have 4x over 5 is equal to 3/10, if I want 4/5 to become 1, what we learned on the previous slide was that I could just multiply by its reciprocal. But if I multiply the left side of the equation by the reciprocal, I also have to multiply the right side of the equation by the reciprocal. This is the multiplication property of the principle of equality. Okay, when I do one side of the equation, I have to do the other side. When I multiply 5 times 4, I get 20. When I multiply 4 times 5, I get 20. So 20 is 1. So I'm going to get x on the left side. Yes. What am I going to get if I multiply this? 15/40. And I hope you don't think you're done at this point. You can reduce that, divide by
3/8, divided by 5.
You can take 5 out of the 15 and 5 out of the 40, you can end up with 3/8. Okay? So x equals. Okay? Bunch of fractions, a lot of people freaked out. I saw it in your faces. Can't hide it. Alright? But if you just multiply by the reciprocal, done. Okay? Anytime you see that a fraction in front of that x, you can always just multiply by the reciprocal, and it gives you a 1 over there instead. 5 times 4, 20, 4 times 5, 20, 20/20 is 1. Okay? Now, if you want me to write the 1 here, I'm more than happy to do that for you. Okay? But it's not necessary. Okay? So fractions, do not let them get to you. Oh, yeah, that's what Sean said. I mean, you can also multiply and then just simplify the fraction, but if you want to reduce, cross-reduce, as you're multiplying, you're more than welcome to do so. And essentially what they did is they said, oh, 5 goes into 10 twice, I'm going to put a 2 here and a 1 here, and then 3 times 1 is 3, and 2 times 4 is 8. Okay? Cross-reducing. Something that you can do to kind of shorten the procedure. It's kind of embedding, reducing the fraction into the problem. You don't do it at the end, you do it as you're doing the problem. Okay? If you were to check, 4/5 times 3/8. Alright? That's going to give you 4 times 3 is 12, 5 times 8 is 40. You get 12/40, but then if you divide both sides, numerator and denominator by 4, I didn't show that stuff here. Or you could cross-reduce. 4 goes into 8 twice. 4 goes into itself 1 time, so you get 1 times 3 and 5 times 2. Alright? 3/10 is equal to 3/10. Negative x equals 4. Okay? And here you can do either one, whichever is your favorite. You can either divide both sides by -1, or you could just multiply both sides by -1. Basically, the only problem I have with this is that the x can't be negative. So I got to get rid of that negative. How can I get rid of a negative? Well, I know a negative times a negative is a positive. So I can just multiply both sides by -1. But also, a negative divided by a negative is a positive. So I can do either one of those steps. Okay? So if you want to divide by -1, you can divide by -1. If you want to multiply by -1, you can multiply by -1. Regardless, you're going to get x equals -4. Okay? If you plug -4 in here, now keep in mind, this is something that we had to be very careful about as we covered 2.1 part B when we were evaluating these last week. Make sure that you put parentheses around that, because now I'm looking at the opposite of -4, which those two negatives are going to cancel each other out and give me a positive 4. Okay? So pretty simple one-step equations. So we're just cruising right along. Applications of linear equations involving multiplication and division. So now we're going to go back to the word problems. Where are we up to now? for the word problems? 1, 2, 3, 3? Okay. So, let's get a few more under our belt. Once again, we're going to read the problem carefully, identify the unknown, assign a variable to my unknown quantity. We're going to write an equation, we're going to solve the equation, then we're going to check our solution. Okay? In these types of problems, specifically, we're going to be setting up the types of equations from 3.1 part C, which is just using the multiplication principle of equality. Okay? An exam is given with 15 problems. And the students are allowed 1.5 hours to take the exam. How many minutes are allotted for each problem? So I give you an exam. It's got 15 questions on it. You have 1.5 hours to take the exam. How many minutes are allotted for each problem? We understand what it's asking. Okay. Let's assign our variable. M is going to stand for number of minutes per problem, right? Okay.
One and 1.5 times
1 and 1/2 times 60. What's that going to give me?
or is it divided by?
No, it's an hour. 13.5 hours.
So you're wanting to convert hours into
Minutes.
okay. So okay, if you take 1.5 times 60, you would get 90. Okay, so you were right the first time, if this is what you're trying to do.
Right.
I was just having trouble understanding. But if you think that an hour, I mean, and most of you are pretty good with time because we use it every day. Okay? An hour is 60 minutes. Half an hour is 30 minutes. 60 plus 30, 90 minutes. Okay? So,
Divided by 15.
divide.
90.
I got to set up an equation.
Oh, okay.
Equals problem.
What?
Equal problem of 15 divided by 15.
I still didn't get the equation there. Yes, sir.
I did my different here. I did 2 times 1 plus 1, and then I set up my equation. 3 over 2 divided by 15 equals number of minutes.
3 over 2 divided by 15.
Well, it's number 1 equals number of minutes.
But then you're using hours and you're coming out with minutes. I'm not sure how that would work out. Let's think about this. The total time it takes you on the test is going to be the number of problems times the amount of time for each problem. It's going to give you the total allotted time, right? M equals what?
90 divided by 15.
I think you're trying to solve the equation before you set it up.
So I was
Like
saying
you're jumping a step ahead.
1 and 1/2 parentheses times 60 divided by 15 equals M.
I think mine was right.
You're trying to get M by itself as you set up the equation. We don't need to do that yet. Okay? The number of problems time per problem equals my number of problems multiplied by the time per problem gives you the total time for the test, or the exam, whichever you want to call it. So if I take the number of problems that I have on the test, I multiply that by the number of, the amount of time for each problem, I get how long it takes me to take the test, right?
Okay.
15 M.
So number of problems, I already have that from the problem, is
15
15
times
times the number of time, the number of minutes per problem.
That's right. Equals 90.
Okay, and I know that the total time for the test, I'm allowed 1.5 hours, which is 90 minutes. We just made that conversion right here. So 15M equals 90. Divide both sides by 15.
Oh.
So we do it on our homework, the way we do it, and get the right answer as long as you see how we got that answer.
I mean, all you're going to have to put into Hawks, well, sometimes Hawks will ask you to put in an equation first.
Yeah,
And
on
you
Hawks
solve
too.
it.
You got to on Hawks.
Okay? And believe it or not, Hawks will accept multiple forms of this equation. If you put in 15x, they probably want you to use x. It'll say it in the problem. 15x equals 90. They would also accept x equals 90 over 15, which some of you were trying to set it up this way because you were, I think you were already, you're trying to solve the equation as you set it up. Really kind of try and segment it. Set up the equation and then solve the equation. Okay? Because as you're trying to work forward, you're trying to kind of get the solution faster. Okay? I understand that you want to do that. But the more complicated these problems get, and the slower you need to work these things out and segment, get the setup for the problem. Okay? Think about it. Well, how long is it going to take me to take the test? Well, if I take the number of problems, and then I multiply that by the amount of time on each problem, I'm going to get the total amount of time for the test. And if I really want to, granted, it's probably not going to take you exactly 6 minutes for each problem on the test. But if you're really wanting to allocate your time as you're taking an exam, you can say, well, I probably shouldn't spend more than 6 minutes on a problem. If I can do that, I'll get done with the test in the amount of time that's given me. All right? It's one of the big problems with the ACT. Does anybody know how many questions are on the ACT?
A lot.
60. Do you know how much time you have on the ACT? 1 hour. So you have 60 questions in 60 minutes. Okay? When I was teaching high school, I taught an ACT prep class. For several weeks, we worked on learning the content of the ACT, what's on the ACT. For the second part of our time, we did timed exercises. I gave them 1 minute to solve a problem. I'd put it up on the board, they'd have 1 minute to work, I'd call time, and we'd see who got it. Okay? Because it's just about working fast. Okay? It's just, kind of a test-taking strategy. Okay? If you know how many problems are on the test, and you know how long you have to take the test, you can figure out about how much time you should be spending on each problem. Okay? One more word problem for the day, right? Alright, so they use x for the number of minutes. We converted 1.5 hours to 90 minutes. We solve for x equals 6. Alright, if the postal rate for mailing books is 19 cents per ounce, what is the heaviest book that can be mailed for $1.71? post office for mailing a book. We know the shipping rate. We know how much money we had to spend. The heaviest book we can mail for $1.71 if the post office charges me 19 cents per ounce.
Can you just divide?
Do we understand? Okay. Identify variable. X equals weight of the book, and this is going to be in ounces. Okay.
multiplied by 19, which is per ounce, and then that equals 171.
Okay. Let's remove ourselves from the problem real quick and the numbers that are up there, and just think about how do they calculate how much you're charged. They take the weight of the parcel. Okay. They're going to multiply that by the shipping rate, and that's how you come up with the cost to send your item, right? I mean, everybody's been to the post office before and mailed something? I mean, never? You've never taken a package in, they put it on the scale, and they tell you how much? Oh my word, how old are you guys? You've never mailed a package to anyone? What? Why are you mailing it? Because it's easier than driving to Chicago to hand it to your friends. You just mail it to them. Oh my gosh, no. You never mailed like a birthday gift or like a care package? Like your friends go off to college and you mail them like something?
Not personally.
U.S. Post Office. You guys don't use it.
I go to
Okay, how did you feel when you received the package?
Oh, no, thank you.
You felt good, didn't it? Don't you want somebody else to feel that? Now, your homework is going to be Hawks and go mail something through the post office. Figure that out. Okay. All right. But everybody's aware that this is how it works, right? Okay. What is the weight of our parcel in this case of the book? What's the weight of the book? X times what's my shipping rate?
419.
Okay, I'm going to write that out here in front just because it's standard procedure to write that out front. So 19 cents times the weight of my book. How much do I have to spend?
1.7.
$1.71. Okay? So 19 cents per ounce. I only have $1.71 to spend. So how heavy can this book be?
Not that heavy. Nah.
What? You get X equals 9? Exactly? No decimal, nothing?
Nope.
Okay, 9 ounces. A little over. Anybody know how many ounces it makes 1 pound?
8.
Oh, you get some conversions. That's good. So this is a little over
Half of it.
half a pound. All right. All right, both right. All right. There is no way that I'm gonna get through 3.2. I think that this might only one more example here in 3.1.